Today we are going to start talking about logarithms. We've done a little bit with logarithms before, but this year we are going to go into a lot more than you got to last year. So in Algebra 2, you just kind of barely touch on what a logarithm is and maybe solve a few simple equations with it. We are going to spend several days on this. Today we're just going to really focus on what a logarithm is, and we're going to look at the graphs of the logarithms. And then next week we'll start solving equations that have logarithms in them. So in general, when you're talking about a log, the base has to be a positive number other than 1. And if you see y equals log base A of x, that A is like a subscript. It's a small number down to the side. In exponential form, that means A to the y power equals x. When you are dealing with logs, the x has to be a positive number. It says the domain x is greater than 0. Here's why. The argument, we call this x the argument of our log. That's like saying a to some power equals that number. Okay, if you take a positive number to a power, is there any way to get a negative answer? No. If you take a positive number to a power, can you ever get 0? No. So that x always has to be positive. What I want to do first, we're just going to take a few examples of going back and forth between exponential form and logarithmic form. Okay, does everybody have that definition written down? So here is our first example. I'm going to take these exponentials, so we just got done dealing with exponentials, and we will write them as a logarithm. Right, log. The base of the exponential has to be the same as the base of the logarithm. So this is log base 1.2. Then you go across the equal sign. So of m. The answer to a log is your exponent. It's like saying 1.2 to what power equals n. So it's the third power. So I always draw in these little arrows when I'm going back and forth to kind of help me. You start with your base and you go across the equal sign. Make sure that when you're writing log base 1.2, that 1.2 is a subscript. Okay, it's kind of down to the side. So this one, I would do log base what? E of. So the answer to the log is always that exponent. Next one, we're going to go the other way. So I'm going to give you the log, and we are going to write the exponential. You have to start at the base. So my base is a, so that means a to the 5th power equals 4. What would the next one be? E to the negative 3rd power equals b. All right. Questions on going back and forth between these ones. So the next thing, the first 2 questions on your homework, they're going to be matching, but they're going to give you a list of logarithms and expect you to evaluate them. So I want to talk about what that means. If I ask you to find the exact value of these things, they're really two approaches we can take. All right, I'm going to work it out first to show you how you could do it as an equation. And then we're going to talk about how I might just be able to look at this and know the answer, especially when you get to those matching questions, and maybe you don't want to work every one of them out. So if you're stuck and you don't know how to do this, you could always say it equals x. We're trying to find out what x is. And then, if I wanted to change this to exponential form, what would that be?
2x divided by 16.
A couple days ago, didn't you have a whole worksheet with problems like this? We got a common base. 16 can be written as 2 to the 4th, and so my x is 4. The answer to this logarithm is 4. So you can write it as an equation. You can also realize that a logarithm is giving you an exponent. So when I say log base 2 of 16, that's asking me 2 to what power would equal 16? The 4th power. So on B, log base 3 of 1 over 27. This is like saying 3 to what power would give you 1 over 27? -3. That's our answer. If you don't see that, then set it equal to x and work it out. This means 3 to the x power equals 1 over 27. Get our common base like we did before, 1 over 27. So 3 to the 3rd is 27. Since it's on the bottom, it would be a negative. And we get -3. So C, could we do this one without working it out? It's saying 2 to what power would equal 1, and that's the 0 power. Does anybody want me to work that one out algebraically? Sure. Just set it equal to x and do your definition. This one is saying 5 to what power equals 25? What if I said log base 7 of the square root of 7? It's like saying 7 to what power equals the square root of 7, and that is 1/2. If you didn't recognize that, anytime you get stuck, you can always do the definition. But we talked about before how a square root is just like a 1/2 power. All right, so do you guys think you could match on that section without having to work out every one of these? Can you look at them and figure out what it's asking? So that's the first piece that we were working on today. Second thing I wanted to talk about was the graph of a log. So there is a relationship between an exponential and a logarithm, which we've kind of already seen when we go back and forth between the definitions. So what we're going to do is graph an exponential and a log here and compare them. So first thing, I want to graph y equals 2 to the x power. What would you do to graph that? And I told you had to plug in 3 numbers. What were they? Okay, so 2 to the -1 is 1/2, 2 to the 0 is 1, and 2 to the 1st is 2. Remember, these always had a horizontal asymptote at 0, because you'll never do 2 to a power and get 0 for your answer. So that is our graph of 2 to the x. Let's graph this one. Y equals log base 2 of x. If I just told you to graph that, what would you do? If we did the definition, that means 2 to the y power equals x. So all I did was flip my x and y here. If you made your t-chart, we know for an exponential we have to plug in -1, 0, and 1 for the exponent. What variable is in my exponent? Y. So I'm going to put -1, 0, and 1 in for my y. So 2 to the -1 is 1/2. 2 to the 0 is 1, and 2 to the first is 2. I'm going to go ahead and just graph it on the same one. So I get 1/2 -1, 1, 0, 2, 1. So how are these things related? They're inverses of each other. Remember we talked about how inverses are symmetric across the line y equals x? Y equals x goes right through the middle. If I fold it on that line, those two overlap. You know, my exponential had a horizontal asymptote at 0. The log has a vertical asymptote at 0. All that happened to my ordered pairs is they reverse. The x and y flipped roles. So this is true then that they are inverses. That means I asked for the domain and range of each. So for, how do I want to put this? All right. For my original, my y equals 2 to the x, what was the domain of that? Negative infinity to positive infinity. What was the range?
0 to 9.
Then when I look at my log, what's the domain of this log? And what's the range of that log? And you'll notice the domain of the first is equal to the range of the second. Range of the first is the domain of the second. And we've already discovered that the domain of the function equals the range in the inverse. And so that's still true here. So a log and an exponential are inverses of each other. In general, to graph a log, we'll go ahead and put it in exponential form and do that t-chart with those 3 points, -1, 0, and 1 for the exponent. And then we could do transformations like usual. So I'd like to practice a few of those, and then I'm done for today. So my first one, f of x, so that's just y, equals log base 1/3 of x. So if I change this to exponential form, it would be to the y power equals x. So my t-chart, we would put the -1, 0, and 1 in for my y, because it's the exponent. So 1/3 to the -1 is 3. 1/3 to the 0 is 1. 1/3 to the first is 1/3. So then we can plot these. 3, -1, 1, 0, 1/3, 1. Will this ever hit the axis, the y-axis here? No, that's like a vertical asymptote. So our graph looks something like that. I would like for you guys to graph the second one. F of x equals log base 5 of x. Let's do a couple involving transformations, and then we'll be done. So just like any other time, if I give you one involving transformations, I would ask you to do the parent function and the final graph. So on this one, I want the graph, and I'm also going to ask for domain and range. So if I said f of x equals log base 3 of x plus 2, my parent function would just be y equals log base 3 of x. So we need to put that in exponential form. So that's 3 to the y power equals x. So 3 to the negative 1 is 1/3. 3 to the 0 is 1. And 3 to the first is 3. Now, what will the plus 2 do? When I move this, what else is going to move? Not just the graph, but also the vertical asymptote will move to -2. And then take each of your points left 2. It will look like that. What's the domain? Prints down to -2. The range? So just like with the exponential, since it had a horizontal asymptote, if we moved it up or down, we had to move that asymptote. Logs have a vertical asymptote, so if we move them left or right, we have to move that with it. Any questions? Last one. What's my parent function? So that means 4 to the y power equals x. Plug in 4 to the y. 4 to the -1. 4 to the 0, and 4 to the first. What will the transformation be this time? Will my asymptote move when I do that?
No.
So domain is still, and range. Okay, so we've worked on the definition of a log and graphing the logs. Both times, if you're confused, you just write them in exponential form, and then it's like stuff that we've done before. So I wanted to give you guys time to maybe get this done so you don't have to take it home. A lot of these are matching questions. 1 and 2 are matching, 39 through 44 are matching. 4 through 10 are just writing a definition, so